Hey everybody, welcome to another video. Today we're going to be tearing down the 1200 series PlayStation 5. This is the third revision in the PlayStation 5 series, and it seems to be following the same lineup that the PlayStation 4 had, where they had the 1000 series, the 1100 series and then the 1200 series, with a major design change coming in the 1200 series. Not design aesthetically, I mean design in terms of the board. So on the 1200 series, the entire board was changed, whereas on the 1100 series, it didn't really have many differences compared to the 1000 series. And as far as I'm aware, it's the same situation with this one. They've got a completely new board, completely new design, new size, and they may be shaping up for a PS4 Slim or a PS4 Pro. We don't know yet. I think the PS4 Pro might have been confirmed. But either way, right now, the current revision and the revision that you're going to be buying in the shops is going to be this one, the 1200 series. I bought this from Amazon brand spanking new. It got delivered on the 29th of December and I've never powered it on. I paid £540 for this just so I could learn this board. The 1100 series PS5 had a few little differences, a few subtle differences. The 5 volt to 3.3 volt regulator on F7002 actually went to a 5 to 1.8 volt reg, and there was a few other small changes to the board for power efficiency and things like that. So I'm expecting to see a lot of big changes. I haven't actually seen any teardown videos myself. I've seen a couple of pictures, but that's about it. And the only reason I'm doing this is because I need to learn the circuit. So this is going to be a technician's teardown, not a consumer teardown. So I will be posting videos on repair guides and stuff in the future. And another thing I'm going to be doing is getting some voltage readings on this so as we can learn the circuits, and they'll all be posted in Discord under the PlayStation section. You can check out Discord. We have got a Discord completely free to use, no strings attached. But you can check out the Discord, link in the video description. And something else that's in the video description is the link to my Twitch channel where I do live streaming. I do live stream on YouTube, but I also live stream on Twitch as well. And this was a very expensive video to make. So if you want to support me, if you want to help me to pay for these kind of things, then you can head over to Twitch. And if you've got an Amazon Prime account, or if a friend or family member has got an Amazon Prime account that they're not using on Twitch, you can link that to your Twitch account and then subscribe to me absolutely free. So Twitch is free to use, but they have got a subscription feature like the channel memberships that YouTube has. And it gives me around about $2.50 every month for everyone that does it. It does massively help me out. And if you've got an Amazon Prime account, it's absolutely free to do. No cost to you at all if you already have Amazon Prime. So I do really appreciate all of the support. It does help me to do things like this. And also there's some direct donation links in the video description, as well as some affiliate links. If you buy anything from AliExpress or Amazon, I'll get a little bit of a kickback on that. And also there's a link to my online store down below as well. It all helps. All of the money from my store comes to me. Most of it is just parts from consoles that I couldn't fix and things like that. But it does massively help me out. It helps me to keep doing this sort of stuff and helps me to keep this channel running. Thank you to PCBWay for sponsoring today's video. As the industry leader in custom PCB manufacturing, PCBWay is the only solution you'll ever need for all your engineering projects. With affordable custom PCBs, flexible PCBs, CNC and 3D printing, you can get your project off the ground today. With the PCBWay store, you can purchase development boards, tools and everything you'll need to get started. Prices are competitive and the possibilities are endless. From multimeters to microchips, PCBWay have it all. And if you're struggling for inspiration, you can find pre-made projects by like-minded engineers. To learn more about the PCBWay store, shared projects, or any of PCBWay's services, head to the video description where you'll find links to the great products and services that PCBWay offer. Now let's get back to the repair. Right we are. So step number one, of course, I need to just power this on and make sure that it actually works. But as you can see, it's in mint condition because I've never powered it on. As you can see, there's no marks on the HDMI. I've never plugged this in at all. And yeah, I think this will probably come with firmware version 6.02 because it is brand spanking new. A little bit of dust what's picked up out of the workshop. It's very dusty in here lately. I do need to clean that up. But as you can see, it's brand spanking new. These are so easy to scratch. It's unreal. But the plan for this, once I'm finished with it, this is going to be my main PlayStation 5. Okay, so this is literally the first time I'm turning this on. So let's hook up a HDMI cable. And yep, so we've got the PlayStation splash screen, so it does appear to be working. I'm going to set this up really quickly, and I'm going to use the included controller with it. So this is a brand spanking new controller. Again, never been powered on, never been used at all. And there we go. Okay, so... no, I don't want the screen reader turned on. So I'll run through the setup really quickly, and then we'll pick it up once I'm finished. And of course it wants an update. Let's skip that for now. I will sign into my account later on, but I want to see what firmware version this comes with out of the box. I'm expecting, well, I think 6.02 is the latest, so I'm expecting 6.0 if it wants an update. 5.5, okay, that's interesting. So this comes with 5.5 out of the box, so I'm assuming that any that are in stock at the minute are going to come with 5.5. I don't think that's exploitable. So by exploitable I mean that you can install custom firmware and things and do some other untold things. But yeah, this all seems to be working fine. I will just hook up a disc quickly. And yep, there we go, the Falcon app. That's my test disc which is installing. Let's just check on storage. So out of the box it reads 667 gigabytes. Okay. Alright, so it seems to be working fine. The disk drive is working, etc, etc. So I'm going to leave this on 5.5 for now. Not for any exploit reasons, but I just can't be bothered to update it, to be honest. So let's tear this puppy down, shall we? A nice virgin console. So right off the bat then, the screws all seem to be in the same positions for the main housing. Yep, we've got the 2 there, we've got 1 there, we've got the 4 there, and then these ones around here. This is slightly different, so one interesting change is the fact that we can no longer access the disk drive power cable from here. So I'm wondering if it's got a different disk drive in it. So we used to be able to access the disk drive power cable. It used to come from here on the daughter board for the disk drive over to here, and when you removed this you could access this cable as well as this cable, but we can't access that now. So that's a bit annoying. So if that cable does get damaged, we have to take this base off, or this top off, to at least get to it, I'm assuming. As you can see, brand spanking new warranty sticker, and that is a factory seal. We are going to, of course, void that warranty. Not legally not binding. There we go. Beautiful. Beautiful. Let's keep that there to forever remember the warranty that was on this PS5. Okay, so the connector that connects up this fan has changed. That's quite interesting. We get a Delta fan in this. Very nice. Slightly different design Delta fan. So this logo wasn't here on the original Deltas. Just there. So the original Deltas was just a blank plate here with Delta around here, or Delta Electronics around here, and then the model number and stuff like that. So that's interesting to see that they have slightly changed that. Whether it's a completely different fan, let's just count the blades on it. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I thought the Delta fans were 23 blade. I don't know. I always thought the Delta fans were 23 blade fans. Let's have a look. So, apart from the fact that this is very, very dirty. Very dirty. So, this has come from a console which I haven't managed to fix. And yeah, that's a 23 blade fan. Interesting. Delta are now making 17 blade fans. So one big issue that people have been having is that they say that the fan is too loud, and that the 17 blade fans are a terrible design, and people do tend to swap over to the 23 blade. So they look on eBay for used ones and things, and this is one of those used ones. So obviously that needs a clean and stuff, but I might put that 23 blade fan into there. I don't know. Well, into here rather. I don't know. Maybe. But yeah, so that's changed. Wow, I do not like that. That is bad. This cable right here on this heatsink, that's bad. The fact that this is just resting on this heatsink, I can see a lot of these failing in the future, these cables, and I can see a lot of disk drive issues going forward. So that is literally just resting on there. It's actually making a contact with the heatsink there. I don't know how hot that would get, but that can't be good for that cable. This plate has changed. So this entire plate here, that is completely different to the original. I'm going to have to do some tests with the thermal cam and see how hot that gets after about an hour of running, and just see if it is going to cause an issue with these cables, or I'm at least going to have to keep an eye on it over the next, you know, year or something like that. Yeah, I don't like that at all. Same with these ribbon cables as well. That just resting on that main heatsink. And another thing as well, this deserves ugly cam, okay? This definitely deserves ugly cam. The fact that the LED ribbon is resting on the heatsink is very, very bad. And the reason I say that is because there's an issue with the PlayStation 5 which has been dubbed, I say called, it's not called anything, it's been dubbed by technicians as the triple beep of death, or the 3 beeps of death. The 3 beeps of death is basically where you turn it on and the console will go to a white light, and then as soon as it goes to a white light and goes through the boot cycle, you get 3 beeps, it goes beep, 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 and then it just shuts off. And that's what's known in the industry as the triple beep of death, or the 3 beep of death. That is caused by that LED ribbon cable, and it's caused by contacts, or rather the traces inside the LED cable actually becoming damaged from factory. So with no technician damage, nothing like that, they're actually melting inside the console. This ribbon cable is genuinely melting inside the console, and not only myself but several other technicians have seen it, and it causes the triple beep of death, and we have to change that ribbon cable. But I've got some footage of that, but I've never made a video on it, because the only video that I did make on it, I wasn't actually filming. I had record on, as I do with every repair, but I essentially took the console apart and I found that issue, as was pointed out by a user on my Discord channel. Basically, that is what causes the triple beep of death, and the fact that this is resting on that heatsink, and the fact that that heatsink is going to get pretty hot, being the primary heatsink which is connected directly to the APU, is bad. It's probably going to cause a lot more triple beep of death issues moving forward. I'm predicting it now. I'm going to come out and say it. I'm predicting that these are going to have a lot more triple beep of death issues than the 1100 and the 1000 series consoles. We'll see. Time will tell. I could be wrong. I could be wrong, but time will tell. I've got a feeling that I'm going to be right here, and I've got a feeling that these are going to have a lot more issues with that particular symptom. Let's carry on with the teardown, shall we? So it looks like we've got less screws in here, a lot less screws than the original. So let's have a look. Let's start taking these out. Okay, I believe I've got all of the screws so as I can get to the board. So a couple of things which I am a fan of. The first thing is this antenna here. So it looks like they've added one more antenna back onto here. So there's now 4 antennas again, or rather 2 antennas, 4 wires. And one thing I'm a fan of here is this antenna here. So one of the annoying things about the PS4 1000 and 1100 series was this antenna just flapping in the breeze, right? So what would normally happen is the plate would cover to about here, and it would go all the way to the end, and this antenna would wrap around the side here, and then essentially it would just come across here, up here like this, across here like this, and it would all sit on top of the plate. And the problem with that is you would have to literally just lay it to rest on the plate and then put the disk drive over the top of it. That was really annoying, because half the time it got trapped, you get it trapped in the case, and stuff like that. So you'd have a few reassembly issues. Now, the good thing about this one is, yes, it's still got these couple of stickers here, which quite frankly don't really do a very good job. But it's got these retention clips here which hold it in, which is good, because that means now that it's not going to get trapped on the case and it's not going to damage the wires. Too many times I had consoles come to me which have been to other technicians, and the wire would be trapped either on the plate here, cutting into it because of the metal plate, or it would be trapped on the plastic here and cutting into it because the top of the case was sandwiching the wire to the bottom of the case. So that there is a good design change in my opinion. So yeah, look at how easy that is to actually unroot. I do like that. Another good design change would be this here. So the USB flex ribbon, we can actually access that without taking the entire plate off now. Just take a few screws out of this plate here, and then we can get to that connector. That's good for repairability, because that means now that we don't have to take all of this plate off and disturb the liquid metal to repair this board here. So one common failure point, which is not Sony's fault really, it's just on the user's end, but one common failure point is the USB Type A port getting damaged. I've seen that quite a lot, and it's annoying to have to take all of the board out just to access this ribbon so that we can change this board or replace the USB port on that board. Now we can access it just by taking that small plate off, and then we can get to that connector. So that is a good change in my opinion. But yeah, that seems a lot easier to take apart, to be honest, than the 1100 series. Heatsink bracket is much smaller. We've seen that a change in that going down the generations, or moving along in the generations. It was quite large, and it got smaller, and then it's smaller again. So I think they are working towards potentially a slim version, to be honest. I know there are leaks about a potential PlayStation 5 Pro, but I don't know. We'll see. That is, wow, so flimsy. There are so many cost-cutting measures on this. I mean, number one, the size of the PCB. I'll show you some comparisons in a second to the other revisions. But number one, just the size of the PCB is going to be so much cheaper, probably 20 or 30% cheaper for them to manufacture this PCB as opposed to the original ones. So, yeah, it's definitely a lot of cost-cutting measures that are being taken here. Get rid of that. Oh, no, there's a few extra screws. So I'm not going to go into, like heat dissipation and things like that. There's other videos out there for that. One thing I will say is this seems a little bit more difficult to take the board out. I think, because I've never seen a teardown of these, by the way. I think pry up on this connector maybe, where the power supply comes in. Just trying to find the best way to get this board out. Oh, there we go. Yeah, just a little bit tight, that's all. That's what she said. There we go. Pop that out, and beautiful. And okay, right, let's discuss the obvious. Okay, so this video is coming right off the back of the liquid metal issue with the PlayStation 5s. Let's take a look at this under the microscope. This has been powered on once, okay? Once. Let's take a look at this under the microscope. I'm going to keep this as flat as possible so as it doesn't affect it, but you can probably already see what I'm going to be referring to here. Wah, wah, wah. Okay, the lighting's not the best because of the reflections, but check that out. We already have what is appearing to be a dry spot forming around here. Typical signature area for a dry spot on the APU, where the liquid metal is supposed to be, and all of the liquid metal forming down on this left hand side or bottom, whichever way you want to look at it. And what's it next to? Of course, the VRMs. So this is where the voltage regulation is going to be going on the main board for the APU. And the issue that we've been having is the fact that liquid metal is basically falling down here and spilling over this little supposed protective foam. So under here, I'm not going to disturb this, but under here we actually have a sticker, or we should do. Let's try and take a peek. I don't want to disturb it too much. Obviously, if this fails, yeah, there is. So we've got that protective sticker right there. And then on top of that is the foam, right? So we've got the foam, we've got the protective sticker, same design as always, but the liquid metal is grouping down here. And why is that? Gravity. Okay? What goes up must come down. Gravity is what is causing that. And yeah, this proves it. This proves absolutely categorically that without any kind of user intervention, without any kind of dropping, this has definitely not been dropped. I can promise you that 100%. It's been sat in the box, hasn't moved, never been powered on. I bought this brand new. This has just been sitting in a warehouse somewhere, and that liquid metal is already starting to form, okay? But anyway, I digress. That is a story for another day. What I'm going to do is I'm going to go under the microscope and we're going to inspect some of the different chips on this and see what's different, what's the same, what I know that we can already buy and things like that. So let's get into it. Let's take a look. Okay, so we'll start up this end. So we've got the Wi-Fi module here on the APU side. This is the J20H100 Rev 1.3. And that, of course, is a little bit different to the original PS5 Wi-Fi modules. So the original PS5 Wi-Fi modules is the Rev 1.0. That Rev 1.0 is on the EDM010 board. And the EDM020 board is very slightly different. Ignore that B on there. Let's just see if we can see this. No, I'm going to have to clean this and get rid of this writing on here. So someone who has worked on this board previously wrote something on the board, on the Wi-Fi module nonetheless. And yeah, let's just get that off by using a bit of isopropyl alcohol. It should come off. It should allow me to see this. Yeah, there we go. So that's cleaning off nicely. So this is the EDM020 board. So we had the Rev 1.0 on the 010 board. And the 020 board is the Rev 1.2. Okay. So, yeah. Slight changes there. Now, in terms of the revision, I do know from experience that the EDM020 Wi-Fi module will work on the 010 module, or on the 010 board. So yeah, I'm assuming that's going to be the same for this. I'm assuming it's going to be the same situation where they're all going to work together. But moving on along, we've got F7002. This is quite interesting because F7002 on the other board was a 5 volt to 3.3 volt regulator on the 010 board, and it was a 5 to 1.8 volt on the 020 board. So I've got those two boards here. So this is the 020. Haven't worked on this board yet, don't know what's wrong with it. But that was the 020 and this was the 010. And if we take a look, F7002 is actually there on the back on both of these boards. So that has massively changed. It's still fairly close to the south bridge, so I think it does go directly to the south bridge. Maybe it comes from the south bridge, putting 5 volts out, and then it goes to the Wi-Fi module and the HDMI encoder from there. But essentially, here is where it is on both of those boards. It looks like it's the same circuit or a similar circuit. Let's just have a closer look. I think it's probably going to be the same as the 020. So the 010 is an SBV chip, or it's marked with SBV. The official chip is a TLV something. But I don't think it's going to be similar to that one. So let's make a comparison to that based on the 020 board. So let's just bring those side by side. There we go. And just look at the size difference on these as well. That's pretty unbelievable how much of a difference there is in terms of actual size. So they have really slimmed down this board. But Anyway, let's just take a look. So F7002, F7002. And if we take a look on the board, it looks, I would say, fairly similar, I think. And I don't know what chip that actually is. Let's just see if I can identify that. No, it's just marked as 022. Okay, well, I'm still going to imagine that this is going to be a 5 to 1.8 volt regulator, I would assume. It looks like they've changed where the fuse is. It looks like we've got a fuse here instead. And not sure where that actually comes in on this EDM 020 board. Yeah, it looks like the same chip. So I don't actually have a source for this component yet, but it does look like roughly the same circuit, apart from the fact that F7002 looks, actually it might be in the same place, to be honest. Yeah, I think it is. So we've got the capacitor there, and then the inductor right next to it. Capacitor and an inductor, yeah. That's exactly the same circuit, I would say. And they are going to be cross-compatible. So next on, we've got the BIOS chip and the safe bridge. Still the 90061GG, so that's fine, we can get those. That's for the main safe bridge where the power rails are generated and things like that. Does look like the battery's been moved and the system speaker, they've been moved quite close together. We've got the RT5126, okay, so that's the same chip that we've got on the other revisions. That's another 5 volt regulator. Got a MOSFET there, F7502. No, that's not related to that. That's going to be RAM power management. Okay, so that circuit there is going to be very similar to, I would assume, this circuit right here on the EDM 010 board, right here. And then F7502, which is just off to the side here. That looks to me like it's not quite the same circuit. So I was expecting to see one of those SBV chips there, but no, that's not quite the same. AQCP 699, something like that. And then a 3219A, that's going to be PWMIC. We should be able to get those, we usually can. I think they're the same as on the other board anyway. But F7502 has changed dramatically. So this is the EDM 010 board, and F7502, as you can see, is one of those SBV chips. So that has changed quite a bit. Whether they're going to be compatible, I don't know. There may be. We'll see. What I might do is I might do some experiments and see what kind of voltages are being put out around there and see if they're the same as on the other boards. Okay, we've got the NOR flash there, which is right next to this SSD controller. So that's all the same. I'm assuming that these are going to be the same. This is probably going to be the CXD 90062GG, which is going to be the same as the other board. And then the SSD chips are going to be the same as well. We have recently found out that those are, or appear to be, replaceable. APU appears to be the same in terms of the layout. We've got some decoupling caps there and things like that going down to the SSD. Other than that, yep, that all seems the same. We've got the RAM, which is going to be on the other side of this board. And then we've got a whole lot of blank space. One annoying thing which I've noticed is, again, the USB ports. As you can see, so the USB ports are going to come from the ports here to the back of the board, and then they're going to come through these wires here around this EMI shielding ground plane, and they're going to come down here. They're going to group up here. And the reason for these wiggly lines is to keep the traces the same length, so as you don't get any kind of latency when the data is passing through. But one annoying thing is it goes straight to the APU, which is actually quite dangerous, because if we get a short on the USB power rails, so the 5-volt power rail, then ultimately what's going to happen is it's going to send 5 volts straight into the APU, and that is not good. They need to change that. So next up is going to be the GST 5009 magnetic module. That is going to be the same as on the other PlayStation 5s. It's essentially to reduce noise on the Ethernet. So it takes 4 pairs of data lines from the Ethernet, so 4 twisted pairs, and it goes through these chokes which are inside this little thing here, and it reduces the noise on the lines, and then it goes out to the Ethernet controller. We've still got the 864739 HDMI encoder, which is good, and we also have a very different HDMI port. So we've now got the Foxconn HDMI port with the metal backing. I do actually have and sell on my website much better quality ports than this. So with this particular port, these ones are very good ports, and these were the ones that we were using for a long time. But there is now another revision, so it's basically revision number 3 on the HDMI ports, and let me show you the comparison between the 3. So rev number 1 on the HDMI ports, we've got that GSF chip there again, or GSF module, but on rev 1 we had these ports here. So essentially the issue with these ports, this was a massive issue where the HDMI port would look fine but people would get no signal to the HDMI port, and the reason for that was because of these pins here on the back. Just like the original PlayStation 4s, they made a massive mistake with the ports, and these pins were popping out of the back of the port. That's been changed. That's actually been changed to this revision here, which is Rev 2, and as you can see it's got a somewhat solid back with this metal plate on top as well. But the revision that I use is essentially going to be Rev number 3, and these are brand spanking new, and these ones have actually got a absolute solid back on them. These are absolutely solid. They are 100% precise in terms of the pin pitch and things like that. They are, as far as I know, a third-party port, but they are very high quality. I'll sell these on my website, consolefix.shop. Shameless shills. But yeah, these are the revision that I use, and these have got a really solid back, very high quality, and I think these are overall better than the original one and the design of these ones here, which they are good ports, and I was using those myself up until a couple of weeks ago. No complaints from me there, but yeah, there are better alternatives available in my opinion. Still got that annoying 0201 capacitor there as well. But yeah, overall this seems the same. The HDMI encoder there, that seems the same. We can get them, they are expensive, but we can buy them. So all of that HDMI circuit seems the same, which is kind of expected given the fact that the HDMI circuit is standard across the board. You know, you need your port, you need your encoder, you need your EMI filters, and you need your voltage management as well. So yeah, that's all the same. These chips here, they're the same. So we've got the 3219A again, so there's a couple of them. They are PWMICs as I said, and they go into the MOSFET and they put out 5 volts, etc, and I think they put like 1.8 volts out or something like that. They are exactly the same as the other 2 revisions, just in a different location. The different location for those is there, just off to the side of the HDMI port, like I said. And this 3219A, you can see that there, it's a common failure point, and a lot of people, well, I wouldn't say it's common. I mean, personally, I've never had it fail, or I've never had one that's gone bad, but quite a few people have reported it as going bad, and replacing that fixes it. We've got the Infineon Power Management IC there. That is exactly the same again as the other 2 revisions. Same place pretty much as the other ones. So that's this chip here. So yeah, we'll be able to get them, whether they're off donor boards or what. We can get those chips. And again, then we've just got the voltage regulators just here. So the actual MOSFETs are going to be on the other side of the board, which is the same as on the other ones as well. Just down to the right hand side of the SSD, it looks like we've got another 3219A which again is going to be a PWMIC. Presumably this PWMIC is going to be for the RAM. I could be wrong, but I presume, given where that is and given the fact that we've got a nice thick trace here, this thick trace here is going to be a 1.37 volt rail for the RAM, I'm assuming. Got the USB-C power management chip there. Sorry, USB-C MUX chip, not power management. That's the same, exactly the same as the other ones. F3502, I don't recall that one. And okay, yes, so we do have F3502 on the other boards, but it is a little bit different. So we've got a fuse there, but on the original EDM010 board, we've got a little chip just here, and then we've got the fuse up here. So that is a little bit of a different circuit, and the part number on this chip, what is that going to be? F2 equals 9E. Did I think they're Einstein or something? I don't know. But either way, yep, that all looks a little bit different. So you're welcome to take those numbers down if you want. If anyone can help me identify these parts, I'm terrible at identifying parts. So I've never seen any of these parts here. These all appear new to me. Well, until we get to these MOSFETs, another 3219A. So maybe that's going to be a common failure point because they are known to fail, like I said. But yeah, who knows? We'll see. I've got that bank of 4 caps there. That's interesting how they've moved those slightly. I wonder if those are different values. I might have to get some readings off that. But I'm assuming that this again is going to be a 5 volt rail. It's pretty much exactly the same as the bank of 4 caps on the other boards. So on the other boards, it's marked as F7501, or well, F7501 is nearby. F3501, let's have a look at that. Yeah, so like I said, these are all different. So those chips we've just seen are not on the original 020 board at all. But the bank of 4 caps I'm referring to is this bunch here, and it was usually one of these that fail when we have a single beat with no light and no power, and no 5 volt coming out through the other side. But yeah, that's pretty much it for that side of the board. So let's have a look at this side of the board, and we'll start off at the 12 volt input. Small decoupling cap there. Don't know what that's doing there, I'll be honest. Not a clue what that is doing there. Why would you put 2 small caps there? But hey, each to their own and all of that. Yeah, so we've got the VRMs just here. I'm looking for this 5 volt area where we're supposed to be getting, or rather where we would normally get 5 volts. I'm assuming it's probably going to be here. I am going to start mapping some of this out, by the way. Don't worry, I will start to get voltage readings for standby voltages, and I will base them off this fully working board as well. So let's just move down a little bit. We've got the connector here for the front panel, for the front USB board. I don't think there's really anything of note here apart from yet another 3219A. So many of those on here. Got another MOSFET there. That is going to be RAM power management. Let's just turn the board around. So that's going to be RAM power management, as I said, with that big thick trace here. So that, I'm assuming, is going to be a 1.37 volt rail, along with the associated MOSFETs. I don't have part numbers for these, unfortunately, but there it is. And then we've got the SSD. Again, same deal as before. It's just the SSD. It's no change. We have the DA9081 dialog IC, and that is going to be a 0.8 volt on this side, so where these 3 caps are, and 2.5 volt when where these caps are when you power the board on. Again, I believe that this is probably related to RAM and SSD power. These chips are all available on the 1100 series as well, I believe. But I don't know the voltage outputs of those off the top of my head. This chip here is available on the 1100 series. That is located just here. So that's going to be, if we've got the RAM on the right hand side, you move across a little bit and then you've got that chip there for that chip So again, yep, same chip, same circuit, same everything, apart from just the location of it. Again, I can't identify that chip, maybe someone else can. We've got Southbridge decoupling, again, next to these connectors here. So these connectors, well, the connector locations have changed, but they're essentially the same. So we've got F5402, this is going to be for disk drive power. And this is going to be, if we get any disk drive issues, this is going to be where we look into. And that's actually located right underneath where this battery is. So it looks like the fuses should be on this side. Let's just have a look. Yeah, so if we get no power on the disk drive, the first place we're going to look is this fuse here. So just like F6202 on the PS4 Slims, this fuse would probably be what's blown if we get no power to the disk drive on these particular boards. Other than that, the disk drive data connector has changed slightly. I do have a disk drive board, or rather a disk edition board for comparison, and yeah, it's much bigger. So I'm not sure how many pins that's going to be. Let's just have a look if I can work it out. It's going to be difficult to see this. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 20 pins on that. And on the original, so this is on the EDM010 board, 25 pins. So there's 5 pins less on this third revision board for the data connections on the disk drive. So now we're going to have to find a source for those as well, and as soon as I do, I will let you know, of course. We have another 5 to 1.8 volt reg there, similar to the SBV chips, so that's very, very similar, although it is in a different place. It's above the decoupling caps for the Southbridge. And I think looking at the original board, so here's the original board, and we were getting a 1.1 volt rail on this inductor just here. So this black component here is an inductor, and we were getting 1.1 volts there, right? So if we look at this board compared to that, then somewhere around this area here, we should get a 1.1 volt rail. But I'll look at that obviously when I produce a pinout for the voltage readings and things like that. These are going to be 5 volt regs for the USB. That's going to be the same as on the other boards. F7001. I can't remember exactly what that actually does. Ah, yes I can. So F7001 is actually supposed to be by the HDMI encoder, interestingly. So I wonder why that's moved. So there's a HDMI encoder, there's F7501, and that goes into this inductor here, and then it goes to this area here which I was talking about earlier on. And okay, that would make sense because it's on the other side of where the HDMI encoder is on this board. Well, okay, that makes a little bit of sense. So pretty much the same circuit there in terms of that area there around by the HDMI encoder. It's just that everything's been flipped. And that is pretty much it. We've got the VRMs, so these are the MOSFETs. These are going to be the same. I'm not going to lift this viscous paste off, but these are going to be the same as on the other board. It's all 12 volt regulation, so the MOSFETs should realistically be interchangeable. Actually, you know what? Stuff it. Let's do it. Let's take one of the. Let's take a bit of the viscous paste off. It's nice and fresh, so it should come off easily. And are they the same? Yeah, they're going to be the same. They're going to be exactly the same as the other ones. Okay, well, that just about does it. So yeah, it's quite interesting really how they've slimmed this board down so much, but all of these power rails, other than 1 or 2 components, seems exactly the same. Yeah, it just goes to show that they really didn't optimise this in the first 2 revisions, and that they are probably working towards a slimmer version going forward. The plan for this now, I'm not going to put this back together. The plan for this now is to get some voltage readings. But let's just take a look at the power supply quickly and we'll see what the difference is between that one and the original ones. Okie doke, and there we go. So that is the inside of the power supply. And we've still got the 450 volt, 150 microfarad capacitors there. I am being very, very careful here in what I actually touch. Let's just have a look and check the voltage inside here. And this hasn't been powered on for 90 minutes now. I did take a break during this video, but this hasn't been powered on for 90 minutes. And let's just have a look at whether there's any charge in the capacitors now or not. So I've got DC volts, and my negative there, positive there. We've still got 120 volts in this. But this is just proof that power supplies are dangerous, ladies and gents. 121 volts, 120. It is slowly discharging. But if I was to touch that right now, it's going to give me a pretty nasty zap. And not just there either. Okay? It's not just there either. The bleed resistors on these don't do a very good job of draining power out of these. But, yeah. I mean, a few things have changed. In terms of the actual power supply itself, a few things look like they've changed on this power supply. Number one is, of course, the positioning of the 12 volt connector. So the connector's here right now. And that's obviously changed. So, ignoring the fact that I've cut the power supply connector off this, I wanted to make a bench power supply cable. But that's the original power supply right there, and as you can see, it's pretty much the same. Yeah, the components are in different places, or some of them at least. Yeah, so like these transistors here are sideways. These ones are, or rather, these are vertical. These ones are horizontal. But other than that, in terms of actual components on this side, this is meant to have a 450 volt cap. I took it off to use in another power supply. But other than that, this seems to be okay. This power supply was dead, by the way. It had been fried. The only difference being that we've got more caps up here, and this connector is different. That's literally the only real change I can see here. We've still got this inductor here, this coil here in the same place. We've got one less cap here. We've got more caps on this one than here. So we've got more capacitors for... more capacitors on this one than this one. I don't know anything about power supplies really. I'm not going to get into any of that. On why things are where they are and things like that. I'm going to be super careful here though. So it looks like we still have a bunch of 3 optocouplers. And I wonder if that's the same DAP 056 chip. Sorry, 053, not 056, my bad. Yep, same DAP 053 chip. DNP 014, I believe that's the same as the ones that are on the other one. That's just going to be for power management. We've got the optocouplers there, the same. Yeah, everything's the same. Everything's the same apart from the positioning of a few capacitors and the positioning of the 12 volt connector. That is super annoying because that means that we've got to find a new source for these power supplies. That's pretty annoying because that's going to be one part that we cannot get, and that sucks. But everything else looks to be in pretty much the same position. Obviously these are in a different orientation. This chip here is meant to be here on this one. This chip here is meant to be here on this one. These resistors are in a different orientation. Diodes are the same. This chip here is the same. The failure points on these, this chip here is the same as well, meant to be there. The failure points on these are going to be the optocouplers, the DAPO53 chip, and there's a couple of little resistors and stuff which usually go at the same time when those fail due to power surges. But other than that, yeah, exactly the same. I can't see any reason why they should have changed this, but apparently they have. So yeah, there is that. So yeah, I hope this video was helpful. This is my little rendition of a teardown. I'm not good at teardowns. I'm doing this for my own comparisons really, so I can learn the board. I hope you found it useful, and it's certainly something that makes life a little bit easier when we're trying to repair these things. If we know the layout of the board, it makes diagnosis and fault finding a lot easier. One thing I'm going to be doing with this board over the next coming weeks is I'm going to be mapping it out. And when I say mapping it out, I mean everything. Every circuit, every voltage rail that I can find. I'm going to map out everything, and I'm going to build not a schematic, because I don't have that kind of skill, but I am going to build something that we can use for fault finding when the console's supposed to be in standby. And then also, again, I'm going to try and do the same when the console is powered on. So if, for example, you've got like a lung pulsing blue light of death, then, you know, maybe you can hunt around and find a missing power rail or something like that. I don't know, who knows. But yeah, look out for that, because that's all going to be posted on Discord. I may or may not make a video going over the actual voltage rails. I haven't decided yet. But yeah, I could make a video where people can reference whenever they need to go over the voltage rails, so as they can visually see as I'm doing it and things like that, and see the readings out on the multimeter. But yeah, we'll see. My cat's just come up into the workshop, so I've got to get this bloody power supply back together. So that's going to be it for this video. Let me know what you think down in the comments down below. Do you find this useful? Do you want to see more stuff like this? Let me know. Yeah, obviously this video has been pretty expensive to make. I mean, I didn't really justify the cost of it based on this video, but yeah, it's still an expensive video to make. £540 this piece of crap cost me. So yeah, I hope you found it useful. I really do, and that is ultimately what the goals of this channel is all about. You know, I try and help people. I try and help people to learn how to fix these things as I learn, and as people follow me along on the journey as new devices get released and stuff. It's all a learning curve. I've got one saying that I live by: the moment you think you know everything is the moment that you stop learning anything. That's going to be from me. Thank you very much for watching, and until next time, I'll see you later. Bye for now.